All right, Olivia, this is section 10.5. We're talking tangents, and I had them draw a little diagram down here of a circle. Okay, here's my circle. A tangent line is a line that touches the circle at just one place. That's called the point of tangency. Okay, if I connect that line back to the radius, it's a 90-degree angle to the radius. So tangent is perpendicular to the radius. There is another thing that we're going to talk about tomorrow that is called a secant line, and he touches at two places. So there is that. That's all the farther we've gotten. Okay, but a tangent line touches at one place. We said this is like a gear going around a bike tire. Okay, no. A chain going around a gear of a bike. Okay, got it. All right, ready? Example 1. Was that 30 seconds?
Sure.
Example 1, common tangents. They're going to take two little bubbles and they're going to give them to you and say, draw a line that is tangent to both of them at the same time. So this top line right here is tangent there because it's only touching at one spot, yeah? But it's also tangent to this guy. He's only touching at one spot. Same thing with the bottom one. The bottom one is only touching here at one spot and only touching there at one spot, but then there's one more. These circles are like butt right up against each other, so I could shove a tangent line in between them, and it's only touching each one of those at one spot, yeah? I don't know why you think that's funny. Whatever. Anyway, tangent lines. There are 3 lines that are tangent, and those are called common tangents because it's commonly tangent to both circles at the same time. B, if I separate those circles and spread them apart, meaning there's a gap between them, I have a tangent line on the top. This is like the top chain of the bike gears, right? Like it would wrap around, right? That bottom chain is also tangent. And then now I have like 2 crosses in the middle. He's tangent here at this dot, tangent here at this dot. He's tangent here at this dot, and here at this dot. Yeah? So now I have 4 tangent lines instead of 3. Good? What happens if I have 2 circles that are one inside of the other? Remember what that's called when one circle's inside of the other? Like ripples in a pond, what? It starts with a C. Concentric. That means same center. So how do I draw common tangents if I have 2 circles, one inside of the other? You can't. Yeah? Like I can't, like if I draw a tangent line here, okay, there's no way I can make him tangent to the other one unless I'm going through. So like this guy on the side right here, this one would be tangent to the inside, but he's actually secant to the outside. Make sense? Okay, so there you go. All right, example 2. AB is a radius. This guy is a radius, and the radius is 9. They want to know, is BC a tangent line? Right? Is it just touching at one spot? Or like if I would continue him on through, like would it end up going through that slightly and like be a secant line instead of a tangent line? How do I know? Is it a right angle? If it's a right angle, it's tangent, right? It's making a T, it's tangent. So can I use these numbers and figure out if he's a right triangle? Yes, except 6 is only this. So what's this whole length here?
18. 9.
15. How'd you get that, Matthew?
3, 4, 5.
9 is from here to here. That's another radius, right? You see this? This and this, yeah?
3, 4, 5.
He is a 3, 4, 5. This is 15. Do you see how that works? Okay. So we're going to do the Pythagorean theorem here in a second, but Ethan said this is a 3, 4, 5. If I divide 9 by 3, whoop, this side is 15, okay? If I take 9 and divide by 3, I get 3. If I take 12 and divide by 3, I get 4. If I take 15 divided by 3, I get 5, and that's a 3, 4, 5 right triangle. So this is a right triangle, meaning that BC is tangent. Yes. BC is tangent. If you need to see that, you could do 9 squared plus 12 squared equals 15 squared, and it would check out, right? Okay? So, there is that. Do you see how that works? Now we get to a hard one. Are you ready? Example 3. Example 3 is a hard one. They say, okay, let's go ahead and say that QS is tangent. So we do, in fact, know that that's a right angle. No guesswork about it. That is a 90-degree angle. What's the value of X? That is a great question.
3.
Okay?
It's 3.
You just wait. We'll see.
I think it's 3. But 3,
Just wait.
4, 5.
He is a 3, 4, 5. Okay.
3.
But here's how you find it out.
Genius.
You're a genius. Okay. This pink side, that's the hypotenuse side. What is the length of this side right here? 2 plus x. I'm going to call it x plus 2. Okay? Do you see how that side is x plus 2? We're adding those together. Yeah? All right, I'm going to do the Pythagorean theorem. Which side is side C? X plus 2 squared. Okay, perfect. 4 squared plus x squared equals x plus 2 squared. That's my Pythagorean theorem, yeah? All right, 4 squared is 16. X squared, we're just going to leave as x squared. But this guy right here, x plus 2 squared, means I have to take x plus 2 times x plus 2, and I have to FOIL. Okay, x times x is x squared. X times 2 is 2x. 2 times x is 2x. 2 times 2 is 4. If I combine these middle two pieces, I get x squared plus 4x plus 4. Okay, so that's that FOILed out. All right, now what?
Subtract the x squared.
Let's subtract the x squared. Oh, but wait. That makes it go away on both sides, right? If I subtract it. So I have 16 equals 4x plus 4. And then what?
Divide.
I'm gonna subtract the 4 first. You could do whatever you want, okay? 12 equals 4x, and then divide by 4, and x is 3. Beautiful. X is 3. So they were right in saying this is a 3, 4, 5 right triangle. Okay, but sometimes they'll get to numbers that are decimals even. Okay, and you're going to want to do that process. So if you recognize that, you can skip those steps. That's awesome. Okay, that was a little bit tricky. All right, let's do example 4. Here's the concept for example 4. You ready for this? This is my favorite thing to teach in triangles or in circles. This is my favorite thing. Right here, what I'm going to teach you right now. This is my favorite thing to teach. Are you ready? Because I'm going to show you. Here's my circle. Whoop. I'm going to draw a line that's tangent to my circle, and I'm going to do it like this. So he's touching at only one place, right? If he would keep going on forever, he would go up. But I'm not going to I'm not going to make him go on forever. Okay? Then I'm going to do this, right? And what's going to happen is those two tangent lines are just touching at one place, right? And they are meeting at one spot. And he makes
Ice cream.
an ice cream cone, right? An ice cream cone. Okay? Now, here's the fancy thing about this. If this side is truly a tangent line, and this side is truly a tangent line, what's true about those two tangent lines? They are meeting, yes. They are the same length, because you know what happens? If one of your sides of your ice cream cone is bigger than the other, then he is going to fall off and make you very sad. Right? So the two sides of your ice cream cone are the same. Okay? Whatever. So this side is 7x minus 9. This side is 5x plus 5. We know that those two things have to be the same because it makes an ice cream cone. Those are two tangent lines. They are asking for the length of AB. So they want to know how long this actually is. We're going to set those two things equal to each other. 7x minus 9 equals 5x plus 5. And I'm going to subtract 5x. So Brian said, is it Brian that said that? 2x?
No, I'm doing.
It is.
Okay, adding 9 is 14. X is 7.
I was close enough.
Sure. X is 7, but they want to know the length of AB. So I'm going to plug 7 back in.
40.
And 7 times 7 is 49 minus 9 is 40. And they say in feet. So AB is 40 feet. So the other one will be 40 feet as well. Now, that wasn't my favorite example. Let me show you this example. This is my favorite example. Are you ready? We're going to skip example 5, which is on the next page. And we're going to go to example 6 really quick. Okay? Go to example 6. We'll come back to example 5, so don't cross it off. Okay? Don't cross off example 5. We're going to come back to it. But we're going to go to example 6 first because this is my favorite thing. Okay? All right, here we go. I'm going to tell you some terminology. All right? And I'll try to make sure the correct word comes out of my mouth. All right? Here you go, because it's circumscribed. I will try to make sure the correct word comes out of my mouth. All right, ready? Here is what I'm about to teach you.
What is that supposed to imply?
The circle is inside the triangle, true? Circle is inside the triangle. So I could say the circle is inscribed in the triangle. Or I could say the triangle is circumscribed. I said that very slowly and made you all very uncomfortable. The triangle is circumscribed around the circle. Both of those statements are correct. Yes? The circle is inscribed in the triangle, or the triangle is circumscribed around the circle.
I feel like that
Makes
would only
sense?
make sense if the circle was around the triangle.
Why is that?
Because then the circle
I know.
it's
Yeah,
in
like
the
circumscribed, you think it should be circles, right? Like the circles. Yeah. Yeah.
That kind of makes sense.
Yeah. Yeah. I get it. 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 Okay.
Wrong, though.
Whatever.
Yeah, well, you got
Okay, good. Happy with that? That's how that works. All right. Now, this is my favorite example to do. I like these. These are like little puzzles, okay? They want to know the perimeter of this triangle. Perimeter is all the sides added together. Ready? You have, let's look at this left side. I have this guy and this guy, which is making an ice cream cone on the left side. And this is 14. So
14.
the bottom is 14. Now I have another ice cream cone on the right side. Whoop, a smaller one, right? And this side is 11, so this side is also going to be 11. And then I have one more ice cream cone at the top. It's a really short one.
That's actually kind of.
And this is 7, so this is 7. And then I have to find the perimeter. So what's this whole side going to be?
21.
21. And this whole side is
25.
25. And this whole side is 18. And I just have to in my calculator, or maybe in your head, I don't care. 46 plus 18 is 64. 64? 64 what? Units squared? Just units, because it's perimeter. Okay, do you see how that works? Those are my favorite. They're like little puzzles. I like them. Okay, but it's just like a bunch of like ice cream cones, like doing that thing, right? Okay, let's go bump back to example 5. Here is some examples of circumscribed polygons. The circle is inside of a triangle. The circle is inside of a four-sided figure, which is called a quadrilateral. The circle is inside of a hexagon. Now, when you're going through and doing each one of these, just remember, there's a ice cream cone. There's an ice cream cone. There's an ice cream cone. There's an ice cream cone, right? Like there's just a bunch of ice cream cones around it. And then you can solve for each one of the sides, right? Okay, same thing here. You got a bunch of little tiny ice cream cones. Boop, 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 whatever, right? Okay, these are not circumscribed. This is what it looks like where it's not circumscribed. Let's talk about this middle one. He would be circumscribed if this side was shoved over a little bit, right? Okay, but it's not. So those are examples. Like we want to utilize the most area possible. So like this is not butt up against the hexagon. So I have some residual space in there and I don't want that, right? So not circumscribed, these are circumscribed. All right, let's talk about example 5. They say that EGF, angle, EGF is this angle right here, and that is 19x plus 9. Put it in there. Angle D is 10x minus 3. If I look at this shape right here as a polygon, how many sides does it have? 4. Do you know how many degrees are inside of a four-sided figure? 360, like a rectangle or a square or whatever that has 360. Okay, but these are 90s, right?
Or 180.
Okay, so if this is 90 and this is 90, then what do these two have to add up to be? 180, right? Because 360 is the total, but those are 90s, right? So 19x plus 9 plus 10x minus 3 equals 180. They're not equal to each other. Obviously, G is bigger than the angle D, right? This looks like a bigger angle. So don't set them equal to each other. 19x plus 6 equals 180. Yeah? Okay. Do you know what my... It doesn't. It is 29x. You're right. I was just trying to spoof you. Okay, this is what drives me crazy. Are you ready for this? This is what my algebra kids like to do a lot, and it just pisses me off a lot. Minus
Whoa, that's a bad
10x
word.
minus 10x.
I would no.
Plus 3 plus 3. Why is that not legal?
Because
It's on the same
They're
side.
both on the same side of the equal sign. Don't do that junk, okay? So, be smart kids, all right? 29x plus 6. They don't do it a whole lot, but every once in a while they do that, and I'm like, no, don't do that. 29x equals 180 minus 6. 174. 29. I'm dropping numbers all over the place. 29x equals 174. Divide by 29. Is it 6?
Yes.
sure.
X equals 6. Okay. Then we have to find the measure of angle D. My diagram is a mess, so I'm just going to look up here and I'm going to plug 6 in there. 6 times 10 is 60 minus 3, 57 degrees. And that's all. Okay? That was example 5. Oh, and we've done example 6, and now we're done. There you go. Boom.
Yeah, look, do it again.
Whoa.
14
Okay.
isn't dumb.
Happy with that?
I suppose.
You suppose. 13 problems. That's not that bad, right?
Well,
Okay.